Right. Yes, where do I start? So hello, I'm Ben Ward. I'm from the Oxford Flood Network. I'm starting to regret calling it the Oxford Flood Network because it's just not applicable to Oxford. It's actually a wider project that's got bigger aims than just Oxford. But as I live in Oxford, I thought I'd better start there. So a bit about me. I'm from Love Hurts. We're a consultancy, Internet of Things and TV Whitespace, which I was here last year talking about. Does anyone remember that last year, TV Whitespace? Wow, 3 hands. Okay, so this is, if you like, the result of talking about TV Whitespace and no one really getting why you would want it. So what I did was I came up with a use case that actually got more attention than the TV Whitespace, which is for those of you who don't know, is a form of new form of wireless communication that will it'd be a bit like Wi-Fi but over long ranges. So Internet of Things first. It's inevitable. Everyone has to put on a slide that says nothing is new. There's something that came before. This is Coke machines on the internet. This was around 1988, I think. You could finger a Coke machine over the internet. Does anyone know what finger is? Okay. For those of you who don't, it's a Unix command called finger. So you're actually connecting to the machine, finding out what users are on it. In fact, what they did there, they just put in the number of Coke cans on in the fridge or Coke machine. So it's got a precedent. There's also machine-to-machine communications, and machine-to-machine communications is kind of the old world. And a lot of people say the Internet of Things is just that rebranded. But I think it's something different. The Internet of Things is bringing together sensors and networks and lots of different information to make something far more valuable. So, for example, here's Safecast. This is actually the inspiration. This is a radiation map crowdsourced by Japanese people putting out Geiger counters around Fukushima because the government weren't giving enough information about radiation levels. Instead, the individuals did. And you see, got a lot of readings along roads there, things like that. So it's all quite crowdsourced. There's probably some slightly illegal sensors out there where people have gone into the exclusion zones. This is slightly less dramatic than a radiation network. This is the Oxford Flood Network's first sensor. You can see it looks quite a lot like a bomb. It's perhaps needed a bit of work. That's version 1. This is version 3. Version 3 looks a lot less bomby. So yeah, the idea of Oxford Flood Network is we put out these sensors under bridges, under people's houses, in their floorboards, in their back gardens, in overhanging bits over the water like this. If there's pubs, we try and find the pubs to do it in, just for the excuse to visit the pub. And what it does is measures the distance to the water. This is another example. This is what was on the screen before, of what happens when you distribute the job of sensing. So that is a lightning strike somewhere south of Venice. It just happened this morning. All those dots, all those green dots, are all the stations that actually recognize that there was a lightning strike. And this is a crowdsourced citizen science, whatever the phrase you want to use, network discovering lightning strikes. This is actually pretty dramatic when you watch it with the sound on. It just clicks like a Geiger counter, I guess. But it's actually measuring time of arrival and triangulating where the lightning strikes are. And if you're interested, it's called Blitzortung, and you can build your own sensor. Sadly, there's no weather in England today, so I had to focus on somewhere else. And there's proof as well, the rain radar, raintoday.co.uk. What I found, though, was I was getting obsessed with looking at both this and this. and trying to layer the information on top of the other. Now, one of the uses of this might be that when the rain radar shows that there's actually rain coming, that the sensors can change their polling cycle. So they save their battery by running for, say, do a 15-minute poll, but flash flooding can happen in a very short space of time. So if heavy rain's due, you can actually tell the sensors to start monitoring more quickly. That's why the Internet of Things, I think, is different from machine to machine, is that you're actually using the rest of the power of the Internet. So back to OX. That's the sensor. So it's a box. You attach it underneath a bridge or something like that. This one's got magnets in. I was going to attach it out there, but zinc doesn't work. So now this is one of the things about sensor networks is you get out there, you get some duck shit on your trousers, and you discover actually this doesn't work. We don't know how to do this. We've spent hours and days and weeks working out a perfect protocol, the perfect way of collecting data. You can't attach a thing to another thing unless you know what you're doing. And I think that's quite an important part of it. As the phrase goes, people with clean hands are wrong, and people with dirty hands are right, because they've actually been out there and seen some of the real world and actually how it works. I'm still halfway dirty hands. I still don't know how to attach this to every kind of bridge or thing that comes along, but it's an interesting challenge to find out. This one's got. Where's Andrew? Is Andrew here? Andrew Lindsay? He's still in the pub. He's the partner in crime on this. Not crime, but crime. They're hard drive magnets that he's put in there. But you can buy magnets in Maplin and things like that. Just to get into some of the detail, this is the elements that make it up. Now, in machine-to-machine world, you might build all this yourself and sell the whole thing to a single customer. The beauty of the Internet of Things is you can break these apart and do them separately. Now, it turns out that we're actually building this ourselves, but we're not creating it from scratch. We're actually using other tools. So the database backend is made by Xively or whoever comes along. The gateway is a Raspberry Pi, but could be reduced if we can find something predictably cheaper than 35 quid for a Raspberry Pi. And the sensors, we've made them ourselves because then they're custom made. So what it looks like is you end up with a lot of sensors attached to a single gateway that attaches to the database, and then you have an API and a map on top. But the API allows you to have anything on top, like a map or a text application, Twitter feed, someone alerts you on Twitter if your house is going to flood, that kind of thing. And that's really just the detail of what the possible software and systems you can use to actually implement it. Now this is what's inside, or at least inside version 1, the bomb-style sensor. Miles from Safecast, is he here? Still in the pub. So all the people, they missed their name checking. The Safecast radio there, the SRF, with an 80 mega 328 attached. So it's basically an Arduino with a radio, but it's that size. So I'll say that size instead of the size of a dev board. And I think that's where this building things on your bench with some breadboard and some wires gets you so far, but you haven't really started when you've done that. You've just proved a concept. When you try and fit it in a case, when you try and find a case, when you try and find a case that doesn't leak, when you try and find a sensor that doesn't actually get affected by humidity under bridges, because that's where it's humid, condensation, all of those things you discover once you've got started. So this is version 2 of the sensor. This is fitting it all onto a board, fits into a box this size again. And then version 3, I didn't get a picture of it actually, but this is version 3. It's got its own custom PCB, and they're not too bad to make, actually. It's quite surprisingly simple to do. You know, come and talk to us if you want to know more about making your own PCBs. Everyone knows what a PCB is, don't they? Printed circuit board. Sorry, I'm not sure. Is it? Are you a technical audience? A 50-50? I reckon. Zero technical. Right. Printed circuit boards. Make your own circuit boards. Raspberry Pi. Who's heard of that? Okay. So the Raspberry Pi is it's got a little radio on top of it, and that actually provides the access to the internet. So this whole thing started off with a different technology as the way to get on the internet. It was a thing called white space, which I've told you about before. It turns out if you can get near a river, you can get near someone's broadband, you've got enough tools to do the job. So all you're doing is reaching this thing over the wireless and then coming back to something like a router and plugging it into the internet. So this Raspberry Pi is just running a simple thing that listens to the data coming off the sensors and then uploading it to the internet. And it's actually probably overkill for what we need. But it's a really good little platform, and it's nice and cheap. And it's also, it's not as scary for some people to have hosted in their house as maybe this unnerving box. You don't know what it does. There's no reason to think that because you don't know what this is doing either, but that's it's just perception. Inside there, this is probably about the simplest Node-RED script you'll see. I gather there was Node-RED just in one of the previous talks. I'm afraid I missed it because of reasons. It inputs the serial data in there, parses it, and then turns it into MQTT output. And that's a sensor map. That's clustered, so you've got a few sensors here. You've got 3 in this area. You've got 2 down at the Hinksey Park. And this is a very small area. So the Environment Agency has 1 sensor there and another one about half a mile that way. And that's just not enough to know what's going on in your area. As the water backs up through here, it comes up this stream, the Thames floods that way, this field gets full. This lake here is a gravel pit, and it actually represents the groundwater, and it starts to come up. And my mum told me never to buy a house in Lake Street or Mill Lane, wherever it is. There's Lake Street. And over here there's flood basements, so flood cellars. So a friend of mine was lifting up his floorboards to see how high the water was underneath his floorboards. And that's pretty scary. He didn't move any furniture for some reason. He said it's rented, it doesn't matter. So this is a little bit out of date because this is using the white space as a backhaul. I say out of date, it's actually ahead of its time. The white space backhaul is about to go in, but you don't really need it. The important bit is the sensor gateway and the cluster of sensors around it. So you have a gateway, attach it to the internet, job done. If you've got no broadband near you, what you can use is white space to be able to reach the hub to be able to get the data back. I say you can use it. You can use it in pilot conditions because OSHCamp haven't allowed it yet, but I'm hoping to show amongst all the other trialists that this is a viable technology to use. That's the problem, is that the equipment's that kind of size. So it looks like you've got a TV antenna. There were a lot of promises a few years ago of very small devices with a tiny antenna, and you could put them in under drain covers and stuff like that. It hasn't happened yet because the legislation hasn't been passed yet, so no one's committed to it. And if you want to know where it fits in, ISM band is what we use for the Safecast radios. And there's tiny little slivers of spectrum here and there. And Wi-Fi, which is what all of these use. All of your Wi-Fi systems will use either this bit here, and literally that tiny gap there, or that one there. TV white space can use all that stuff. So I think it's quite useful. I think there's a lot of benefit in there. The only downside is you have to share it with the TV. So where the TV is using it, you're not allowed to use it. And what you do is you look up in a database, a white space database, to find out which channels are available. And then effectively, it's like tuning your Freeview box. It just scans through and uses the nearest available channel that hasn't got quiz programs on, things like that. So, where next for Oxford Flood Network? Well, I have pleaded in the past for, please help us, please come and join us, commit to GitHub. Precisely 2 people are committing to GitHub, me and Andrew. I'd be interested probably in taking a step back and finding out how to engage the technical community to push it over the line to make it useful to the geographical community, if you like, the normal people. Sorry. But the people who don't know how it works and don't care how it works, they're just happy to be able to put this under their floorboards or put this under a bridge and look after it on behalf of their community. And then gather this information together to produce something that's beneficial to all. I think to do that, we probably need the locations. So I'm hoping we're able to leave one here in Hebden Bridge and actually build the Hebden Bridge flood network, which goes back to what I was saying earlier about it's not an Oxford thing. It's wherever you need it. If anyone knows how to organize a community around a technology, or at least around an aim, and then transition that to a community of normals, then I'd be very pleased for that. Anyone who knows how to attach things to things, so this to a bridge, to something made of stone, something made of wood, without getting in too much trouble, without making it too permanent, then that would be really useful. We're planning to have a hardware hack day down in Oxford. Hebden Bridge was a long way to come from Oxford, but I guess you guys might want to come down to Oxford. And it'll be a sensor workshop, if you like, building other types of sensors. So the one where this doesn't actually help you, what you can do is you can put in things that measure the actual depth of the water rather than the height of the surface. So actually sit in the river. And just enthusiasm, ideas, we like ideas. Ideas why it won't work, well, they're useful. Getting out there and showing us it doesn't work, that's even more useful, I guess. And if you're a bedroom hacker, then Oxford FloodNet on GitHub, you can start contributing straight away. There's a lot of stuff to do with it's more about the back end that needs developing now. So the sensors, we've got down to a level where actually it does something useful, it's robust, and it's got an external antenna, and we've got a design for it. Now we really need to work further up that stack and get the applications going on top of it. So if anyone wants to come and talk to me about it afterwards, or if you want to join in the workshop tomorrow, what we're going to do is go and put out a sensor. We're going to have a hub or several hubs in here because it's broadcast, so you can pick it up from any device that listens using the right protocol, and actually look at how we upload it to the internet and how we could improve that, but also get something practical out there that will live on once we've gone. And maybe next year we can come and see it again. And hopefully it won't get washed away, and hopefully we won't even need the sensor. That's me.